Um, got her. Thanks, buddy. Yeah, so you're gonna see I've never done this before. Every year I've taught logs, I have brought these out on the first day. And this year I was like, push it, push it, push it. And I feel like I'm kind of glad that I did. So there are two kinds of logs that are not difficult to work with. I just need to make sure that you're familiar with what they are. The first thing you're going to notice is that you're going to start encountering logs like this that don't have a base. And it is not like your teacher or your book or whatever is forgetting something. The answer to log of 100 is 2. Let's see if you can help me crack the code. This is a very special kind of log, hence the name of the notes today. Yeah. What do you think the base is? It is 10. When you can't see a base on an log log, and I'm saying log for reasons you'll soon understand, when you can't see the base on an log log, it is what we call a base 10 log. The name of a log with a base of 10, I'm going to put this in quotes, I do want you to know this, is called a common log. And this is where I kind of spiraled out of control earlier today, and I'm going to try to keep this reined in because I'm kind of a nerd. But I want you guys to really stop and think about our number system. And I know you probably don't want to think too much at this point right after lunch, but think of that it's not a coincidence. In the metric system, when I move a decimal place, what did I do? Times or divide by what? 10. If you move a decimal two places, what did you multiply or divide by? 100. Listen, these are called powers of 10. And do you know why we work in a base 10 number system? It's really important to me that you know this. Why, oh, why do we use 10 as our base for our number system? How about this? Here are the numbers we use in our number system. I really thought that maybe we had talked about this, so now I'm kind of glad that we are nerding out today. Um, these are the things we use every number we ever write consists of these, right? What do we call those? What are these called? They're numbers. Starts with a D. These are the digits that we use in our number system, right? So we talk about like a 3-digit number, like 349, or a 2-digit number. Our number system consists of 10 digits. Do you guys know another name for a finger? It's called a digit. And if you've never stopped to think about this before, the first time you ever really let it sink in, it's really just kind of almost like mind-alteringly cool. We have humans, whatever it is, if you believe that we've evolved to have 10 fingers or that we were created to have 10 fingers, that's neither here nor there. The point is, as humans in our history, we have 10 of these things. It is not a coincidence that our number system that we work with on Earth as 10-digit beings is a 10-digit number system. We call this a base 10 number system. So having said that, the fact that humans in mathematics always use tens, our entire metric system is based on powers of 10, right? This is not a coincidence. Everything is based on the fact that we have 10 of these. I have a schoolhouse rock that I may show you later that's really actually pretty cool that kind of brings up the idea of what would happen if we had been, again, evolved or created to have 6 fingers on each hand. It's amazing. If we had 6 fingers on each hand, our metric system, when we move a decimal place, what would we be doing? Not 6. We'd be multiplying by 12. And if you move a decimal two places, we'd actually be multiplying by 144. Instead of 10 times 10, one for each movement, we'd be going 12 times 12. And I don't mean to get all weird and talk too much number theory with you, but I really want you to understand and respect why the number 10 is so ubiquitous. Like, it's because of this. It's because humans have 10 of these. And as we created our language and discovered the world around us, 10 was convenient because we could count things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we didn't have 10, we would have a different number system. And it's amazing. And if I get time, I'll show you the Schoolhouse Rock. You don't have to watch it, don't care. But it's neat because again, it talks about what if we were little aliens who had 12. And there's an alien in the video called Little 12 Toes. That's like what the song is about. So sorry. I could talk about that more, but I'm going to move on. I need you to know that a log where you don't see the base, log log, is called a common log, and there is a base, and it is 10. So if you see a log, like you will all over the place from this point on, like log of 10,000, what is the answer? It is 4. Okay. If it makes you feel better to put in a base, go ahead. Like I'm not gonna, you know, I need you to know that it's there. It's just called a common log. And your calculator has a common log button, by the way. There's a button that just literally says log. That's your base 10 log button, okay? In case you were wondering. The other logarithm you're going to see is this. And that is not on your paper, that number 5 does not say like IN or 1N. That is a lowercase L when it's written in, I think, Times New Roman or something. So this stands for, and again, I need you to have the vocab. This is called a natural log. And I emailed myself a YouTube video. I scoured YouTube yesterday for like a half an hour looking for a video that I thought would explain what I'm about to talk about. So I'm going to give you a sort of cursory look at what we're going to talk about, and then Monday I'll show you a video that explains this. But do you guys all know what pi is? When I say what is pi, I know most people say it's like 3.14, and then some people get fancy and add like a 159, and some people then look over at the wall and start reading more numbers to me. But I don't want to know what numbers make up pi. I'm going to ask you a question. What is pi? What is it? Do you know this from geometry? It's not the circumference of a circle, but it involves the circumference of a circle. You could find pi in this room right now, probably 30 or 40 different places. Pi is a number that no one invented. Pi is a number that just happens. It literally just happens. It is a number that mathematicians and scientists have continued to learn more about, but no one made it. It exists. If you went home tonight, grab a dinner plate, and then find something that you can use like a cloth, like a sewing tape or a sewing measuring. I don't know what they call that. Like, you know those tape measures, but they're like made of cloth and they're all bendy and foldy. If you were to take a dinner plate tonight, you go home tonight and you grab a plate and you set it on the counter, and you were to take that cloth tape measure and measure from here all the way around to here, you get something that's called the circumference of a circle. Not exciting. But you'd want to measure very carefully. Like you don't want to half-hearted go, oh, use about 10 inches. Like make it good. And then if you were to take that dinner plate and very carefully figure out where the longest distance across the circle is. By the way, these things are called chords. Like this is not the chord I'm talking about. That's not the longest chord. The longest chord stretches from the 2 furthest points of a circle like this. Do you guys know what that's called? That's called the diameter. If you were to take any circle of any size, it could be a huge crop circle out somewhere in like Ireland or in Nebraska. It could be a tiny little circle. Any circle in the world. If you divide its circumference by its diameter, you will always get pi. Pi, I need you to know is, and I'm geeking out a little bit here, and the reason is because the number we have to talk about next is like pi, maybe as useful as pi. But I need you to know what pi is. When people ask you what's pi, it's okay to say 3.14, but really at the heart of it, what a guy like me wants to hear you say is it's the ratio of a circle's circumference to its diameter. And I mean any circle. You could turn that water bottle over and measure the bottom of its circumference, measure the distance across, divide it. Hot dog, I just got about 3.14. How cool is that? That's what pi is. There's a new number today. And by the way, pi is, I think you know this, pi is what we call an irrational number, right? Do you guys know what it means to be irrational? It, it goes on forever and it never repeats. That's the key. There's lots of decimals that go on forever. Like if I took 1/3 and I made it into a decimal, it's 0.3 forever, right? But why Point three, repeating is not irrational is because it repeats. If a decimal has a pattern, it's not irrational. But the thing about pi is that it'll never repeat. If you could find 500 trillion places of pi, it would never repeat. There's never a pattern. And that's pretty cool. Anyways, it is, goes forever. It's infinite. It has infinitely many decimal places and it never has a pattern that repeats ever. And the same can be said of our new friend, that guy. You need to write him down. He is not a letter. It's a number. And I have a video ready to show you, but it's not today. That's going to show you what E is. But E is a number that occurs naturally in the world. And like I said, it's even more really practically useful for most mathematicians, scientists, physicists. It's everywhere. This number E is like pi. He's an irrational number. He goes forever. He never repeats. And he starts out as about 2.71828. Kind of in the same way we might say pi is 3.14159. We know we're not really doing it justice, but it's a good place to start. Did you guys bring your calculators today? If you have one, grab it. You're going to find a button on there that says this. In fact, the button doesn't say that. The button says this, ln, and then above the button, you'll see e to the something, e to the x. So what I want you to do is hit second and then hit your natural log button, and it's going to bring this up on your screen. What I have in purple is, I think, what it's going to say. Does that sound about right? And then I just want you to hit the number 1. And the reason for that is because I just want us to see with our own eyes what is e to the 1th power. Hit enter.
2.71281828.
There's your 2.71828, so on and so forth. If you had an infinite number of human lifetimes and a calculator screen that was infinitely long, you could never find the end of the number e. And we will talk about that in more detail on Monday. I don't know if you find stuff like this interesting, but numbers like this number in particular is really, 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 really important in mathematics. And finally, I can tell you, why are we talking about this? This seems so random. It's because of this ln that you see on your paper. You see it on number 5?
Mm-hmm.
A natural log is this. It's a log with a base of e. In the same way that when you see a naked log like log without a base is a base of 10, right? ln is an log with a base of e. So having said that, let's look at how hilariously simple this can be. What is the natural log of e to the 10th power? Ready, go. Yes. And the reason for this is because it's redundant, and I can prove it to you. Ready? What is ln? It's a log, yes, with a base of e. And what is log base e of e to the 10th? It's 10. What is the natural log of the 5th root of e? It's 1/5. What is the natural log of e to the 74th? 74. What is the natural log of 1 over the 5th root of e cubed? -3/5. Eventually, we are going to apply the number e to answer questions about like continuously compounding interest and exponential decay and stuff like that. For today, what I really need you to know is A, he's a really cool number, and B, the natural log is just a log with a base of e. Having said that, what is your answer to problem 4 on the practice quiz? Question 4 on the practice quiz. The answer is 5, because it's a log with a base of 10 that you can't see. Having said that, what is your answer to problem number 5? 1, because it's a log base e of e, and so on and so forth. So I apologize that took so long, but I'm not sorry enough that I wish I hadn't said it. That's the kind of geeky stuff we need to start talking about, is like e. What is it? And on Monday, huh? It is. And on Monday, I'll show you kind of how E came to exist. I watched like 10 videos that involved like differential equations, and I was like, no, this isn't what I want. And then I found one that was like plain English, perfect. So I'll cue that one up on Monday. Oh, Schoolhouse Rock, yes. I can't record it because I think that's like against YouTube policy. So
Copyright.
yeah, so I'll stop my recording. Anyways, I can say it in the recording. It's Schoolhouse Rock. It's called Little 12 Toes. It's really good.